South Korea built one of the best tanks in the world without any real experience in tank design. $8.5 million for a single tank. That's not a typo or a joke. It's the actual price of a fighting machine that Guinness World Records officially recognized as the most expensive tank on the planet. For that kind of money, you could buy 3 luxury penthouses in Manhattan, 10 brand new Lamborghinis, or a small passenger jet. But South Korea decided that's exactly what their K2 tank, nicknamed the Black Panther, should cost. And the most surprising thing here isn't even the price. It's who built this machine. A country that just 40 years ago had zero experience in designing armored vehicles suddenly leapfrogged every major player in tank design and rolled out something truly extraordinary onto the global market. To understand the scale of this achievement, we need to go back to 1985. That's when the Republic of Korea produced its first main battle tank, the K1. Though calling it fully Korean was a bit of a stretch. Its design was based on the American XM1 prototype by Chrysler Defense, the same platform that evolved into the M1 Abrams, but it was far from a direct copy. Korean engineers, working with General Dynamics, adapted the vehicle significantly for local conditions. It was smaller, lighter, and featured a unique hydropneumatic suspension absent from the Abrams. The engine and transmission came from Germany, an MTU diesel and a ZF gearbox, while the fire control system was American-made. Korea was still heavily reliant on foreign expertise, learning the craft step by step. But officials in Seoul understood perfectly well that this couldn't go on forever. The country's demographics weren't looking great. The population was aging, birth rates were dropping, and fielding a massive army like North Korea's simply wasn't an option. The South made a bet on quality over quantity. One high-tech tank was supposed to be worth 10 of the enemy's outdated machines. So in 1995, the Agency for Defense Development received an ambitious mission: create a fundamentally new combat vehicle that would embody the most cutting-edge technologies available. Korean engineers started by thoroughly studying all the global tank-building expertise they could get their hands on. They had a unique advantage that no one else had. Thanks to their alliance with the West, they gained access to American and European developments. And through intermediaries, they were able to closely examine Soviet and Russian machines as well. They took apart German Leopards bolt by bolt, studied American Abrams tanks, analyzed Israeli Merkavas, and even got their hands on the secrets of Russian T-80s and T-90s. The best of everything humanity had created in armored warfare ended up on the desks of Korean designers. The initial plans were wildly ambitious. Engineers wanted to build a tank with a fully unmanned turret, where the crew would sit inside an armored capsule within the hull, protected from any kind of hit. The main gun was supposed to be an experimental 140mm cannon from the German company Rheinmetall, capable of defeating any known armor in existence. The Koreans were aiming to create the tank of the future, a 21st century machine that would leave every competitor in the dust. But reality had other plans. The Germans unexpectedly shut down the 140mm gun development program. Their specialists concluded that existing 120mm guns with newer ammunition could handle any foreseeable armored threat. Spending billions on a new caliber was deemed unnecessary. The Koreans had to completely redesign the entire project. The unmanned turret was also scrapped. The technology of that era simply couldn't make it reliable enough. But the most serious problems showed up where nobody expected them. South Korea was absolutely determined to equip their tank with a domestically built engine and transmission. This was a point of national pride and strategic necessity. Relying on foreign suppliers for critical components of a combat vehicle was simply unacceptable. Korean companies took on the challenge of developing a 1,500 horsepower powertrain. Years went by, they burned through cash, but a working engine still didn't materialize. The tank's design was largely complete by 2007 when the first prototype was unveiled. 13 years of intense work, with the total project cost reaching 452.6 billion won, over $230 million spent on research and development alone. The hull, turret, weapons, electronics, everything had been perfected. The only thing missing was the machine's heart. The Korean engine stubbornly refused to cooperate. It overheated, broke down, and couldn't deliver the promised power output. Engineers attacked the problem again and again, but without success. On March 2, 2007, at the proving ground in Changwon, journalists, military attachés, and defense officials from around the world gathered. South Korea was about to unveil its new tank, and expectations were sky high. When the armored vehicle rolled onto the demonstration area, a surprised murmur rippled through the crowd. The Black Panther looked predatory and futuristic, like something straight out of a sci-fi movie. But the real story wasn't its appearance. Under the hood of this beast sat a German MTU 883 engine and a transmission borrowed from the Leopard 2. The Koreans acknowledged their temporary setback. After over a decade of struggling with their own powertrain, they made the pragmatic call to use proven German components. National pride took a back seat to the need to finally get the machine into service. That said, the engineers never gave up the dream of a fully Korean tank. Work on a domestic engine continued in parallel with serial production. And the Black Panther's weapons system exceeded every expectation. The main gun was a 120mm smoothbore L-55 cannon designed by Rheinmetall and manufactured in Korea under license. But it wasn't the gun itself that made the K2 special. It was what it could do. The autoloader allowed a firing rate of up to 10 rounds per minute. No crew in the world can manually load a gun that fast. The ammunition load was 40 rounds. 16 shells were stored directly in the autoloader, ready for immediate use. The remaining 24 were stowed in racks inside the hull. That kind of supply allowed sustained combat without resupply for quite a while. But the most interesting part wasn't the number of rounds. It was the variety. The standard loadout included next-generation tungsten armor-piercing, fin-stabilized, discarding Sabot rounds. Their heavy alloy penetrator left the barrel at incredible velocities and could punch through the composite armor of modern tanks like it was paper. The ammunition also included multi-purpose shaped charge rounds, similar to the American M830A1. These were equally effective against infantry, light armored vehicles, and even low-flying helicopters. But the real crown jewel of the arsenal was a round developed specifically for the Black Panther. Korean engineers created an intelligent top-attack munition called the KSTAM, inspired in part by the German DL-SM Art 155 artillery round. The round was fired on a high arc trajectory, like a howitzer shell, climbing high above the battlefield before descending toward the target from above. Any tanker knows that the turret roof and upper hull are the most vulnerable spots on any armored vehicle. That's exactly where the KSTAM struck. During its descent, a parachute slowed the munition, while its infrared sensors detected the target below. The round then formed an explosively formed penetrator, a high-velocity metal slug that punched through the thin top armor. The crew just had to fire in the general direction of the enemy. The smart munition did everything else. This technology turned every K2 tank into a mobile artillery system, capable of hitting targets behind cover and on reverse slopes of hills, places a conventional tank round simply can't reach. Secondary armament included a coaxial 7.62mm machine gun and a 12.7mm anti-aircraft mount on the turret roof. The anti-aircraft machine gun could be operated remotely, so the commander didn't need to stick his head out of the hatch under enemy fire. The fire control system tied all these deadly tools together. A millimeter-wave radar on the front of the turret constantly scanned the space ahead. Thermal imagers could detect targets in total darkness and through smoke. A laser rangefinder instantly determined the distance to the enemy. A crosswind sensor automatically adjusted the aim. The ballistic computer processed all the data and delivered a ready firing solution. An automatic target tracking mode allowed the crew to lock onto an enemy vehicle and keep it in the crosshairs regardless of their own tank's maneuvering. The gunner pressed a button, and the system tracked the target on its own. The thermal imager's detection range extended out to 9.8 kilometers. At that distance, the Black Panther could spot the enemy long before they even realized where the threat was coming from. The commander's panoramic sight provided a full 360-degree view. The commander could take over control of the turret and gun from the gunner at any moment if a higher priority target appeared. This dual control setup significantly boosted the crew's combat effectiveness. The Korean Peninsula is an absolute nightmare for tank crews. Mountains and hills cover 70% of the terrain, cut through by narrow valleys and countless rivers. There are no vast plains where armored columns can deploy in classic battle formations. Every kilometer has to be fought for on steep slopes, among rocks, and marshy lowlands. The Black Panther's engineers knew this better than anyone and built a machine that takes to this kind of terrain like a duck to water. The secret lay in a hydropneumatic suspension with electronic control. Each of the 12 road wheels, 6 on each side of the hull, had its own hydraulic cylinder managed by the onboard computer. This system let the tank perform maneuvers impossible for any other vehicle in the world. On rough terrain, the suspension automatically raised, increasing ground clearance to maximum levels. The tank literally lifted itself off the ground, keeping its belly out of reach of rocks and stumps that would wreck the running gear of an ordinary machine. On highways, the opposite happened. The system pressed the hull down to the asphalt, lowering the center of gravity and improving stability at high speeds. But the real magic started when the crew switched the suspension to combat mode. The Black Panther could bow forward, raising its rear and dipping its nose. It could lean backward, lifting the front of the hull high off the ground. In that position, the gun barrel could elevate to angles impossible for conventional tanks. This turned the vehicle into an improvised anti-aircraft platform, capable of engaging low-flying helicopters and ground attack aircraft. On Korea's hilly terrain, this capability offered a massive advantage. The tank could drive onto the reverse slope of a hill, lean back, and fire at targets on the crest while remaining nearly invisible to the enemy. The classic tactic of using terrain, what tankers call a hull-down position, took on an entirely new dimension. Side-to-side tilting solved another problem. When a tank crosses a slope laterally, it normally leans, and the crew has to fight against the uncomfortable angle. The Black Panther simply leveled its hull relative to the horizon, compensating for the slope. The driver, gunner, and commander worked in comfortable conditions, not wasting energy fighting gravity. The powertrain matched the designer's ambitions. The German MTU 883 diesel produced 1,500 horsepower. With a combat weight of 55 tons, that gave a power-to-weight ratio of 27.3 horsepower per ton. The automatic transmission with 5 forward and 3 reverse gears meant it could change direction in a heartbeat. On paved roads, the tank could hit 70 kilometers per hour. Off-road, it comfortably maintained 48 kilometers per hour, an outstanding result for a 55-ton machine. Accelerating from a standstill to 32 kilometers per hour took just 7 seconds. That kind of agility let the Black Panther rapidly reposition, pop out from behind cover for a surprise attack, and vanish before the enemy could return fire. The ability to climb vertical obstacles up to 1.3 meters high and tackle slopes of up to 60 degrees made the tank practically unstoppable on any terrain. But the most impressive trick was one the Koreans saved for last. Rivers on the Korean peninsula aren't wide, but there are tons of them. Building pontoon bridges under enemy fire is both incredibly dangerous and painfully slow. South Korean military planners wanted their tanks to cross water obstacles without any outside help whatsoever. and the engineers solved that problem in the most radical way possible. The Black Panther was equipped with an underwater driving system that allowed it to cross rivers up to 4.1 meters deep. Preparation took about 30 minutes. The crew installed a special snorkel tube that fed air to the engine and let the crew breathe. This same tube served as the commander's observation post, allowing him to watch the surface. The turret was fully sealed, turning into a watertight capsule. The hull, however, was intentionally flooded with nearly 2,000 liters of water. It was an ingenious solution. Air inside the tank created excess buoyancy that threatened to lift the vehicle off the bottom. The water counteracted that effect, keeping the tracks on the riverbed. The tank crawled along the river bottom like a giant iron crab, invisible to the enemy on the bank. Upon emerging onto dry land, the Black Panther was ready for combat almost immediately. No lengthy preparation, no vulnerability while exiting the water. A purge system cleared the water from the hull in minutes, and the machine was back to being a fully capable fighting unit. Every tank is a compromise between firepower, mobility, and protection. Strengthen one, and designers inevitably sacrifice the others. But Korean engineers decided the Black Panther wouldn't play by those rules. They created a multi-layered defense system that turned the K2 into one of the most heavily protected tanks on the planet, without sacrificing speed or firepower. The first line of defense was modular composite armor. The exact composition of this armor is still classified to this day. What is known is that it's a complex layered sandwich of steel, ceramics, special polymers, and other materials, capable of withstanding both kinetic and shaped charge munitions. The modular design allowed for rapid replacement of damaged sections right in the field, without sending the vehicle back to a factory. On top of the composite base sat blocks of explosive reactive armor. Each block contained a slab of explosive between two metal plates. When a shaped charge round hit, the explosive detonated, flinging the metal plates outward. This counterblast disrupted the shaped charge jet before it could burn through the main armor. Against rockets and RPG rounds, this protection worked beautifully. But the engineers understood that passive armor alone isn't enough in modern warfare. Anti-tank weapons were getting more and more sophisticated, and sooner or later, any armor would be breached. Something fundamentally new was needed, and the Koreans turned to the concept of active protection, a system designed to destroy threats before they even arrived. Mounted on the Black Panther's turret was a millimeter-wave radar, constantly scanning the surrounding space. This system operated like a guard that never slept and never blinked. It detected incoming missiles and shells, instantly calculated their trajectory, and determined the projected point of impact. The onboard computer received this information fractions of a second before a potential hit. Then the automated defenses kicked in. If the threat was non-critical, the system launched visual and infrared smoke grenades in the direction of the attack. A dense curtain blinded the seekers of homing missiles, causing them to lose their target. Grenade launchers were positioned on both sides of the turret and could create smoke cover in any direction within moments. 4 laser warning sensors constantly monitored whether anyone had the tank in their crosshairs. Many anti-tank systems use laser guidance, painting the target with a beam that the missile follows. The moment these sensors detected such illumination, the computer automatically swung the grenade launchers to the right direction and deployed a smoke screen. The crew might not even realize what had happened. The machine had already protected itself. The radar system was complemented by an electronic warfare station. It could jam the radar homing seekers of anti-tank missiles, throwing them off course. Combined with the smoke screens and infrared decoys, this created a virtually impenetrable electronic shield. But the true technological breakthrough was the Korean Active Protection System, designed specifically for the K2. Its operating principle was simultaneously simple and brilliant. A 3D radar and thermal imager detected incoming threats at distances of up to 150 meters from the tank. Within milliseconds, the system identified the type of munition, its speed, and its trajectory. If evasion was impossible, the last line of defense activated. A specialized interceptor projectile launched toward the threat and destroyed it at a distance of 10 to 15 meters from the tank's hull. The explosion occurred far enough away to avoid damaging the vehicle, but close enough to guarantee the intercept. The system could neutralize rocket-propelled grenades, anti-tank guided missiles, and even certain types of armor-piercing rounds. The cost of a single such system came to $600,000. Korean military planners intended to equip every Black Panther coming off the production line with one. However, in 2014, the integration program had to be postponed due to budget constraints. The tanks were manufactured with provisions for installing the system, but without the actual hardware. The military expected to revisit the matter when funding allowed. Inside the vehicle, the crew was protected by an entire safety architecture. Ammunition was stored in a special compartment with blowout panels. If a round was hit and detonated, these panels would blow outward, directing the blast energy away from the crew. An automatic fire suppression system monitored temperatures in all compartments and could extinguish a fire within seconds before the flames reached ammunition or fuel. A collective NBC protection system created positive pressure inside the tank using filtered air. Nuclear fallout, toxic gases, and biological agents couldn't penetrate the interior. Atmospheric sensors constantly analyzed the outside air and alerted the crew to any hazards. The first 15 production K2 tanks were delivered to the South Korean Army in June 2014. Nearly 20 years had passed from the launch of the development program to the day the Black Panther finally took its place in the battle line. These vehicles were immediately sent to units stationed along the demilitarized zone, separating the two Korean states. This was the front line where war could break out at any moment, and only the very best weapons would do. The North had thousands of aging tanks, Soviet-era models, and their locally built copies. The numerical advantage was overwhelming. But in terms of quality, these machines were hopelessly outdated. Against the Black Panther with its smart munitions, advanced sensors, and multi-layered defense, they stood little chance. And it was this machine that sent shockwaves through the global defense industry. The first major foreign interest came from Turkey. In 2007, Ankara began negotiations with Seoul, and in July 2008, Hyundai Rotem and Turkey's Otokar signed a technology cooperation and design assistance contract. The Turks had long dreamed of their own modern tank and launched a program called Altay, but their domestic industry lacked the necessary know-how. The Koreans offered a solution. Turkey gained access to K2 chassis and suspension technology, using these developments in their own project. In return, Korean companies landed a substantial contract and strengthened their position in the Middle Eastern arms market. The Turkish Altay became, in many ways, a descendant of the Black Panther. Same layout, similar hull contours, analogous running gear solutions. Of course, the Turks introduced plenty of their own modifications and used different weapon systems. But the foundation was laid by Korean engineers. It was a stamp of international recognition. The real triumph came later, when talk of buying Black Panthers started in Europe. Poland, the largest military power on the eastern flank of NATO, had been operating aging equipment for decades. Its arsenal included Soviet-era T-72s, upgraded PT-91s, and second-hand German Leopard 2s. All of these machines were in urgent need of replacement. Warsaw announced a massive tender for modern tanks. European and American manufacturers had their eyes on a lucrative contract. The Germans offered their Leopard 2s, and the Americans pushed the M1 Abrams. But the Poles surprised everyone by signing a framework deal with South Korea in July 2022 for up to 1,000 K2 tanks. The first executive contract covered 180 K2s, built in South Korea, worth $3.37 billion, with the remaining 820 vehicles, a modified K2PL variant. to be manufactured in Poland under license. It was the biggest tank deal in Europe in decades. Why did the Poles choose a Korean machine over proven Western hardware? There were several reasons. Price played a role, but it wasn't the deciding factor. The main argument was speed of delivery. European factories were backed up with orders, and new tanks would have taken years to arrive. The Koreans guaranteed deliveries would begin in the shortest possible time frame. For a country bordering an active military conflict zone, speed of delivery trumped everything else. The K2's technical specifications fully satisfied Polish military requirements. The vehicle was perfectly suited for the European theater of operations, with its extensive road network and numerous water obstacles. The ability to ford rivers without building bridges was especially valuable in terrain crisscrossed by tributaries of the Vistula and Oder. Alongside its export success, Korean engineers were working on the next generation of the Black Panther. The K2 PIP modification was set to receive a whole range of revolutionary upgrades. The semi-active hydropneumatic suspension was to be replaced with a fully active system. The difference was fundamental. The new system was designed to include high-resolution terrain scanners capable of analyzing the ground up to 50 meters away in all directions. The computer would receive a three-dimensional map of the surface and calculate the optimal position of each road wheel for clearing obstacles in advance. The tank would literally anticipate rough spots and prepare for them seconds before contact. Ride quality and off-road speed were expected to improve dramatically. Explosive reactive armor was to be replaced with non-explosive reactive armor. This type of armor worked differently, absorbing the energy of a round mechanically, without detonation. This was safer for infantry accompanying the tanks in battle. Traditional explosive reactive armor sent shrapnel flying dozens of meters when triggered, potentially hitting friendly soldiers nearby. Non-explosive modules didn't have that drawback. The most ambitious plans involved the armament. Engineers were considering the installation of an electrothermal chemical gun instead of a conventional one. This type of weapon used a plasma igniter that ensured more complete combustion of the propellant charge, significantly increasing the muzzle velocity of the round. Armor penetration would increase by tens of % without changing the caliber. If you enjoyed this deep dive into how a small Asian nation built one of the best tanks in the world, hit that like button and drop a comment about what other military tech you'd like to learn about. Subscribe to the channel so you don't miss new episodes on the most fascinating machines of war.